Good morning, sir. This is Murthy, chemistry lecturer, having 20 years of experience at the college level and 3 years of experience at the school level. And today's my demo topic is electrochemistry. And what is electrochemistry? How can we define electrochemistry? So electrochemistry is a subject which deals with the interconversion of chemical energy into electrical energy and electrical energy into chemical energy. So that is about the introduction of electrochemistry. And before getting into the details, we should discuss about conductors. What are conductors and insulators? So what are conductors and what are insulators? So generally we know what are conductors. Any substance which can conduct the electricity can be called as a conductors. For example, metals, aqueous solutions. So a conductor is any substance which can conduct the electricity. So for that we have given the examples as metals and aqueous solutions. And what are insulators? Insulators are nothing but the substances which do not conduct electricity. For example, rubber, plastic, wood. So these are the insulators. So these are the substances which do not conduct the electricity, and these are the substances which do conduct the electricity. So the substances which do conduct the electricity are called as conductors, and the substances which do not conduct the electricity are called as insulators. And again, conductors are again of two types. So conductors are of again two types. Number one is metallic conductors. Metallic conductors. Number two is electrolytic conductors. Electrolytic conductors. So conductors are of two types, that is metallic conductors and electrolytic conductors. But what are metallic conductors? So these are the substances which do conduct the electricity by the free movement of electrons in the solid state without undergoing any chemical change are called as metallic conductors. So what are metallic conductors? So these are the substances which do conduct the electricity by the free movement of electrons in the solid state without undergoing any chemical change. So those can be called as a metallic conductors. For example, the metals, different metals, alloys, graphite. So these are called as a metallic conductors. Then what are electrolytic conductors? So these are the substances which do conduct the electricity by the free movement of ions. So here, by the free movement of ions, these electrolytic conductors can conduct the electricity by the free movement of ions in the aqueous state or in the molten state by undergoing some chemical change. Such substances can be called as electrolytic conductors. So these are the substances which do conduct the electricity by the free movement of ions in the aqueous state or in the molten state. Such substances can be called as electrolytic conductors. Examples as we can give: acids, bases and salts. So acids, bases and salts come under electrolytic conductors. So this is about the general discussion of metallic conductors and electrolytic conductors. Now, then what are electrochemical cells? Electrochemical cells. Electrochemical cells. So what are these electrochemical cells? So in today's modern world, we use many number of electrical devices in which batteries are available. In those batteries and all, those batteries are nothing but the electrochemical cells in which the chemical energy is converted into electrical energy, and electrical energy is converted into chemical energy, vice versa. But how can we define these electrochemical cells? So these are the devices in which two metal electrodes can be dipped in the same or different electrolytic solutions. What are these electrolytic solutions? These are nothing but the aqueous solutions of acids, bases or salts. Can be called as electrolytic solutions. So these electrochemical cells are the devices in which two metal electrodes are dipped in the same or different electrolytic solutions, which converts the chemical energy into electrical energy and electrical energy into chemical energy. So therefore electrochemical cells are of two types. One is galvanic cells, or it is otherwise called as a voltaic cell. These are otherwise called as voltaic cell. And the other one is electrolytic cells. But what is this galvanic cell or a voltaic cell, and how can we define this galvanic or voltaic cell? So this is also a device in which the spontaneous redox reaction is used to convert the chemical energy into electrical energy. So what are galvanic cells? So these are the devices in which the spontaneous redox reaction is used to convert the chemical energy into electrical energy. And what is this word spontaneous? Spontaneous in the sense any reactions which can take place on its own without any initiation. Such reactions can be called as spontaneous. It happens on its own, or the reaction takes place on its own. So the spontaneous, the chemical reaction, the chemical energy of the spontaneous redox reaction is being used up to convert into electrical energy in these devices, right? And moreover, here in the galvanic cells, two metal electrodes will be dipped in two different electrolytic solutions. In these galvanic cells, the two metal electrodes are dipped in two different electrolytic solutions. And coming for example here for the galvanic cell, we have one example as a Daniell cell. So Daniell cell is a galvanic cell in which the spontaneous redox reaction takes place, and that is nothing but zinc reacts with the copper sulfate, producing zinc sulfate and copper. This is a spontaneous redox reaction. It is a spontaneous redox reaction, and the chemical energy of this spontaneous redox reaction is used to convert into electrical energy. So here zinc is highly reactive than copper, so zinc replaces the copper, producing zinc sulfate. So that is about a galvanic cell or voltaic cell. And coming to the electrolytic cells, what are these electrolytic cells? These are also the devices in which the electrolysis of non-spontaneous reactions are used to convert electrical energy into chemical energy. So these are the devices in which the electrolysis of non-spontaneous reactions are used to convert the electrical energy into chemical energy. So here the word non-spontaneous, what do you mean by the word non-spontaneous? Non-spontaneous means any reactions which do not take place on its own, it requires some initiation. Such type of reactions can be called as a non-spontaneous. For example, electrolysis of water. Electrolysis of water. If we take, that is decomposition of water. The decomposition of water or the electrolysis of water, it doesn't take place on its own. It needs some initiation. It requires some initiation in the form of electrical energy. For example, see, water gets decomposed. So water gets decomposed into hydrogen and oxygen. So water gets decomposed into hydrogen and oxygen, and this is a non-spontaneous reaction. This reaction will not take place on its own. It requires some initiation in the form of electrical energy. So this electrical energy is used to convert into chemical energy. So electrical energy we are supplying so that decomposition takes place and it gets converted into the chemical energy. So that is about the galvanic cell and the electrolytic cells. Coming to the, we'll discuss later about the galvanic or voltaic cell in detail, that is Daniell cell. And these electrolytic cells, if we take, then what is this electrolysis? So electrolysis takes place in the electrolytic cells. So we'll discuss about electrolysis. So electrolysis. What is this electrolysis and how can you define this electrolysis? So it is the process by which the decomposition of electrolytes takes place by supplying some electric energy in the by supplying some electric current in the form in the aqueous state or in the molten state of the electrolyte in the electrolytic cell. So electrolysis, it is a process by which the chemical decomposition of the electrolytes. What are electrolytes? Acids, bases and salts. So these are nothing but the electrolytes. So the chemical decomposition of these electrolytes takes place by passing some electric current in the aqueous state or molten state of the electrolytes in an electrolytic cell. So all this process will be taking place in the electrolytic cells. For example, if we discuss one example, that is electrolysis of dilute HCl using platinum electrode in the electrolytic cell. So electrolysis of dilute HCl using platinum electrode in the electrolytic cells. So the electrolysis process will be taking place in the electrolytic cell, and for that I have taken one example, that is electrolysis of dilute HCl using platinum electrodes. So this electrolysis, what is taking place in the electrolytic cell, it has only a single compartment. It has only a single compartment. That means the two metal electrodes are dipped in the same electrolytic solution. So these are the two metal electrodes dipped in the same compartment. So this is nothing but dilute HCl, nothing but the electrolyte. So this is the electrolyte. So this is the electrolyte. Dilute HCl we have taken as the electrolyte. This dilute HCl gets decomposed. That means it undergoes ionization. And these two metal electrodes we have taken. One metal electrode will be acting as a anode, and the other one as a cathode. That is electrode. What electrode we have taken? Platinum. One will be taking as a cathode and the other will be taken as anode. So this is platinum anode, this is platinum cathode, and this will be having a positive charge here. So anode will be having a positive charge and cathode will be having a negative charge. So here the anode will be having a positive charge since it is connected to the positive terminal of the battery. It is connected to the positive terminal of the battery. So it is connected to the positive terminal of the battery. So here we are taking the similar type of electrodes, platinum electrodes. The two platinum electrodes are dipped in the same electrolytic solution, right? So these are dipped in the same electrolytic solution, that is dilute HCl, and the anode is positive here and the cathode is negative, because this anode, since it is connected to the positive terminal of the battery, it is positive, and this is cathode is connected to the negative terminal of the battery, so it is negative here. And at the cathode, hydrogen gas will be liberated, and at the anode, chlorine gas will be liberated. Okay, so this is the simple diagram of this electrolysis. And coming to the ionization. So what is ionization or decomposition? Here what is undergoing ionization? HCl. So HCl undergoes ionization as H plus and Cl minus ions. And here, since we have taken dilute HCl, this is in the aqueous state because water is being added here. So it is in the aqueous state. So water also gets ionized here as 2H plus ion and OH minus ion. So here we have two cations and two anions. So we have two cations, similar type of cations, but here the anions are different. So which cation here, since cations are similar, cations reach the cathode. So cathode is having a negative charge. Cathode is having a negative charge. So negative charge, the cathode having negative charge attracts the cations having positive charge. So these cations, they reach the anode or they get discharged at the the cations gets discharged at the cathode by let me explain it like this. First we'll take the anode. So anode, we know that it is having a positive charge. So anode is having a positive charge, cathode is having a negative charge. So as we know, the cations are attracted towards the cathode and anions are attracted towards the anode. So here but we have two anions, chloride and OH minus ion. Among these two anions, which anion will be discharged at the anode? That depends upon the preferential discharge theory, or it depends upon the lower discharge potential. So among these two anions, chloride ion is having a lower discharge potential, so therefore it gets discharged at the anode. It gets discharged at the anode undergoing oxidation. So at the anode, always oxidation will be taking place at the anode. So what is oxidation having? Actually, losing of electrons is nothing but the oxidation. Losing of electrons. That means the Cl minus ion, it loses one electron. It loses one electron. It loses one electron, converting into chlorine. So since we have taken two Cl minus ions, so that it loses the two electrons, converting into chlorine gas. So this chlorine gas is liberated at anode, as you can see. So chlorine gas will be liberated at anode, and at the cathode what happens? This H plus ions gains the two electrons, undergoes reduction. The H plus ions gains the two electrons, undergoes reduction. So what is reduction? Gaining of electrons is called as reduction. So the H plus ions, they discharge at cathode having a negative charge, undergo reduction by gaining the electrons, converting into hydrogen gas. So this hydrogen gas is liberated at cathode, and chlorine gas is liberated at anode. So here the anions, when the two different type of anions are competing with each other to discharge at the respective electrode, it depends upon the lower discharge potential. The ion having lower discharge potential, the anion having lower discharge potential will be discharged at the anode with respect to that of OH minus ions. So OH minus ions will not be discharged at the anode. In spite of that, chloride ions will get discharged at the anode, undergoes oxidation by losing two electrons, converting into chlorine gas. Chlorine gas will be liberated at anode by undergoing oxidation, and hydrogen gas will be liberated at cathode by undergoing reduction. So this is all I want to explain as far as the demo class. So thank you, sir.